You ever come across a story that makes you pause and just think, wait, humans have been trying to figure this out for a century and now a machine just cracked it? That's exactly what we're talking about today. It's one of those moments where the line between human curiosity and machine capability just blurs a little. And before we dive in, I want you to imagine being a scientist back in the early 1900s, scratching your head over a problem that everyone says is unsolvable. Fast forward 100 years, and an AI, a very patient, very analytical kind of brain, just gave us answers that were, well, let's just say enlightening. So what exactly are we talking about? For the last century, scientists have been wrestling with a mystery in a field that might sound a bit niche at first. Think chemistry, physics, biology, all tangled together. It's a type of puzzle that's small in scale but massive in implication. The kind of thing where the answer doesn't just solve one problem, it opens doors to dozens of new questions. For decades, researchers tried the usual methods, experiments, observations, simulations, but the results never fully lined up. Something always seemed off. Let me give you a sense of the challenge. Imagine trying to assemble a 1,000-piece puzzle, but every time you try a piece, it slightly changes shape depending on how you place the other pieces. Now imagine trying to do this puzzle without a picture on the box. That's what scientists have been dealing with, except instead of puzzle pieces, they're dealing with molecules, particles, and forces that behave in ways we understand mathematically but not perfectly in real life. The inconsistencies were tiny, but they mattered. They were enough to keep the problem unsolved for generations. And this is where AI comes in, not as a flashy miracle worker, but as a kind of super precise assistant. Think of it as a tool that can look at every possible configuration, every tiny variation, and weigh them against the data in ways our brains can't practically do. It doesn't get tired, it doesn't get bored, and it doesn't make careless assumptions. It just calculates, evaluates, and refines until patterns emerge that were invisible before. Now I know what some of you are thinking. Richard, AI has been solving problems for years. What makes this one different? That's a fair question. The difference here is twofold. First, the mystery itself wasn't just about raw calculation. It involved understanding complex relationships and subtle interactions over time, something traditional computational methods struggled with. Second, the AI that cracked it wasn't just following a formula, it was using what you could call a sort of guided exploration. It analyzed the historical data, it learned from decades of failed experiments, and it suggested pathways that human researchers hadn't considered. In short, it connected dots that had been scattered across 100 years of scientific work. What's remarkable isn't just that it found a solution, but how elegantly it did so. The solution doesn't just patch holes in our understanding, it reshapes how we think about the system itself. It's like staring at a blurry image for years and suddenly noticing the outline of a face you didn't know was there. Everything you thought you knew about the problem suddenly fits into a bigger, clearer picture. I want to pause here and make this relatable. Imagine trying to fix a clock that's been broken for decades. Every attempt you make seems to work, but only partially. Some gears move correctly, others slip, and you're never sure if the problem is the gears themselves or how they interact. Now imagine trying to have someone, or something, that can simulate every possible gear combination at once, check for tiny misalignments, and finally tell you the exact configuration that will make the clock tick perfectly. That's basically what this AI did. And here's the thing, this isn't science fiction. We're not talking about some mystical AI knows everything scenario. The AI didn't invent new laws of nature. It used existing knowledge, applied it in an unprecedented scale, and recognized patterns that were too subtle or too numerous for humans to see. It's a reminder that sometimes progress isn't about new discoveries in the traditional sense, but about looking at what we already have in a smarter, more comprehensive way. You might be wondering how this discovery could affect everyday life. That's another interesting part of the story. While the mystery itself is highly specialized, the implications ripple outward. Understanding this phenomenon more accurately could impact materials science, energy storage, even certain medical applications. Imagine being able to predict behaviors in systems that were previously too unpredictable. The potential applications are vast, though it will take years to fully explore them. I also want to reflect on what this means for the human side of science. There's a tendency to think of AI as replacing us, but I see it differently. AI in this context acts like a collaborator. It's extending our reach, not taking over. Scientists still had to design the problem, interpret the results, and verify the solutions. The AI provided clarity, but humans still provide context, judgment, and creativity. It's a partnership that shows how technology and human expertise can complement each other in profound ways. Now let's talk a bit about the process itself, because it's fascinating. The AI didn't just run a single calculation and stop. It went through iterative cycles. Each cycle involved testing hypotheses, checking them against the historical record, learning from discrepancies, and then refining its approach. It's almost like watching a detective solve a cold case, except the detective never sleeps and can consider millions of leads simultaneously. And here's a subtle but important point. The AI wasn't just looking for one answer. It was looking for patterns, for the relationships between variables, and for explanations that could account for anomalies. In doing so, it didn't just solve the immediate problem, it generated insights that scientists can now explore further. That's why this breakthrough is as much about process as it is about the solution itself. I think what's most striking is how patient and methodical the AI was. One of the challenges of scientific discovery is human impatience. We often want answers quickly, and that can lead to errors or shortcuts. The AI doesn't have that limitation. It can take the time necessary to examine every possibility, and in doing so, it uncovers solutions that aren't obvious, but are robust and reproducible. And it's important to remember that this doesn't happen in isolation. The AI builds on a century of work by countless scientists. Every experiment, every failed attempt, every partial theory contributed to the dataset it used. In a way, the AI is standing on the shoulders of giants, but with the ability to see connections that giants couldn't. It's a reminder that scientific progress is cumulative, and sometimes it just takes the right perspective to bring everything together. Let's pause and reflect for a moment. Think about how many times in life we face problems that seem unsolvable, where all the pieces are there but nothing quite fits. This story is a lesson in persistence and perspective. Sometimes the solution isn't in doing more of the same, it's in approaching the problem differently, in combining knowledge in ways that weren't obvious before. And while AI makes it look effortless, it's actually a combination of human ingenuity, careful data collection, and the right analytical tools. You might also be curious about what this means for AI itself. Some people fear AI breakthroughs as if they're unpredictable forces, but this example is grounded, practical, and transparent. It shows that AI can amplify our understanding without being mysterious or uncontrollable. It doesn't replace critical thinking, it enhances it. And that's a subtle but important distinction that often gets lost in the conversation about technology. Before we move forward, I want to address a common question. Can this approach be applied to other long-standing scientific mysteries? The answer is yes, but with caveats. The AI is most effective when it has a rich data set and a clear framework for evaluation. It's not a magic wand, but it is a powerful tool for exploring complexity. Problems that have been resistant to traditional methods might benefit from this approach, particularly when the challenge involves subtle interactions or patterns hidden in layers of data. And here's a fun way to think about it. Imagine you've been trying to understand a complicated board game for years. You've read the rulebook, watched others play, tried your own strategies, but you keep hitting dead ends. Then someone comes along who not only understands the rules, but can simulate millions of games in a matter of minutes. That's essentially what this AI did. And what's equally interesting is the speed at which the AI reached its conclusions. What took humans decades of trial and error was resolved in months. That doesn't diminish the human effort. It highlights the scale of what AI can add. It's a multiplier of human insight, not a replacement. And in many ways, that's the most inspiring part of this story. And this brings me to a subtle but profound reflection. Science has always been about curiosity, persistence, and careful observation. What this breakthrough shows is that our tools are evolving, allowing us to ask questions in ways we couldn't before. It doesn't change the fundamental nature of science, it deepens it. The human qualities of curiosity, skepticism, and creativity remain central. AI is simply helping us navigate complexity that was previously overwhelming. So what's next? Now that this mystery is solved, or at least much more clearly understood, scientists are turning to applications and extensions of the solution. They're exploring new materials, predicting behaviors, and designing experiments that were previously impractical. The AI has provided a roadmap, and now it's up to humans to walk it, explore it, and expand it further. And I think that's a perfect note to reflect on.
Progress often comes in partnership. The AI provided precision and scale. Humans provided intuition, judgment, and context. Together, they achieved something neither could accomplish alone. It's a model for how technology and human expertise can work hand in hand, especially as the questions we face become more complex and interconnected. And I also want to emphasize something subtle but important. Breakthroughs like this don't happen in isolation. They require a foundation of careful work, accumulated knowledge, and collaboration across generations. The AI didn't invent the science, it illuminated it. It showed us what we couldn't see on our own, and in doing so, it respects the work of the scientists that came before. That's a perspective we often lose when we talk about AI in dramatic terms. And finally, let's circle back to the human element. This breakthrough is exciting, yes, but it's also grounding. It reminds us that curiosity, patience, and careful thinking are still essential. AI is powerful, but it's not magic. It's a reflection of what humans have been trying to understand for 100 years, and in that sense, it's deeply human. So, as we wrap this part of the story, I want you to think about the broader picture. What does it mean to have tools that can process complexity at a scale we can't grasp? How do we combine these tools with human judgment